All right, so welcome to your second video on the your Unit 5 Covalent Bonding Study Guide. So again, as a reminder, the things that will help you with this, specifically with number 5, is going to be this assignment, this assignment, the modeling covalent bonds, and then the honk 1, 2, 3, 4 rule. So that's just a continuation of number 4. And also the notes that will help you with this one is also going to be the honk 1, 2, 3, 4 notes. And then also the other thing that will help you is the covalent bonding notes and also the covalent bonding tutorial. So all of those things that we've done so far will certainly help you figure out how to get to what you need. All right, so first of all, so I'm going to zoom in a little bit for this one. So we got C2H2Cl2. So the first thing I need to do is I'm going to draw the valence electrons for carbon. I'm going to connect those two because they are connected. And then I'm going to make sure both of these get one of those hydrogens. So this one has a hydrogen and this one gets a hydrogen. So I'm going to draw those like that. And then I need to make sure each one has a chlorine. So chlorine, as a reminder, has 7 valence electrons. So you can do it this way. There are actually a couple of different ways we can approach this. I'm going to show you just one other way to do this here in a moment. So you've got that right there. So what do we have left over? So hydrogen has its one bond, because hydrogen only ever make one bond. Chlorine has its one bond. Carbon has this carbon right here, 1, 2, 3, has 3 bonds. Doesn't have its 4th bond. Same for this carbon, only has 1, 2, 3 bonds. Doesn't have its 4th bond. So what do you notice here? We've got 2 electrons, they are ready to bond. This is where we're then going to end up having a double bond. So I'm going to show you briefly how it could look another way. So I'm not going to do this for every single one of the molecules, but I will do it for this one specifically. So especially the double bonding ones. So this one, another way to do it is, so we've got 2 carbons. We know that carbon needs to have 4 bonds, so we've got 2 carbons. This carbon needs to have 4 bonds, so I'm going to put 4 lines coming off of there, 4 lines coming off of there. I'm going to make sure both of these has 2, each one gets 1 hydrogen. Then this one gets a chlorine. And this one gets a chlorine. Doesn't matter the order, but make sure that you distribute those atoms to everybody. So then you see that you've got, oh, both of these carbons need to have a bond. So then you could then connect those like that. You can even go even faster where you're like, oh, it could be like, you see that you've got hydrogens, and it doesn't matter. You could have one atom having 2 chlorines and another one having 2 hydrogens, but it's a little bit easier if you do it the way that I was showing you. So next one we've got is CH3Br. That does not mean that there are 3 CHs. That means that there's 1 carbon, 3 hydrogens, and 1 bromine. So we've got carbon. I'm gonna do that way. We've got 3 hydrogens. I'm going to draw a line to there. So that means this carbon here only has 3 bonds. And then let's check real quick to make sure so bromine on the periodic table, we've got bromine. Bromine is in the same row as chlorine, is in the same row as fluorine. Bromine has 7 valence electrons, so then it needs to have 1 bond in order to be having its octet satisfied. So we've got bromine with 7, then we can connect that last one. Excuse me. All right, so that's what that one would look like. So then we got CH3OH. We're gonna start out with 1 carbon. I'm gonna do this little shortcut that I just mentioned to you. I've got 4 bonds. Carbon will always make 4 bonds. I'm gonna have a hydrogen, another hydrogen. You can choose to put those electrons on the end, but you can also use the 1 line to represent 2 electrons. So you got 3 of those hydrogens. When you got that OH, I talked about this in class, that tells you that you've got an O, then that it has your H there, and you've got your valence electrons for oxygen right there. So because oxygen will always make 2 bonds whenever we're looking back to what we did for the last video, all the way down to number 3 right here, about option 3C. All right, so coming to letter D. Letter D is going to be similar to letter A. So I'm going to start out with carbon. I'm going to have both of those have 4 lines. And here we check it out. We've got 2 iodine. So 2 iodine. Here we have oxygen, fluorine, chlorine, sulfur, selenium, bromine, and then here we have iodine. Iodine is also in the same group as fluorine, so and iodine is then going to have valence, 7 valence electrons. So I'm going to have 7. So that means that these will pair here. Iodine will also be here. So iodine's satisfied. It's got its total of 8. 1, 2, 3, 4, 5, 6, 7, 8. But carbon still doesn't. This is another one of those where it's similar to letter A. Letter A had a double bond. Letter D will have how many bonds? Or between the 2 carbons? If you thought third, you were correct. So this would be a double bond. And then this right here would give it a triple bond. So that was letter D. Then we've got letter E. We got P2. So P2, we got phosphorus has 5 valence electrons. I know that because it's in group 15. But I drew out the entire Bohr model for phosphorus. You'd see that it had 5 valence electrons. So you got P. One thing to then look back to is to number 3 on your on page 1. Page 3 on page 1 is the same group as nitrogen. So if you look to find out how many bonds nitrogen has, nitrogen needs, just like phosphorus, needs 3 more bonds in order to satisfy its octet. So then this means that there would be a triple bond. Excuse me, triple bond. There. So it looks something like that. Or you could do shorthand. You could do something like that if you knew it was like that. All right, then we got S2HF. That means that there's 2 sulfurs. Sulfur is in the same group as oxygen. So therefore, it's going to have 6 valence electrons. Excuse me. 6 valence electrons. We got 6. Got 2 of them. In order to have 6 valence electrons, 8 electrons, it's going to have 2 bonds. So this sulfur now has 1 bond. I'm going to give this sulfur another bond with hydrogen. And then I'll give this sulfur also its other bond. All right. So this next one's going to be a little bit trickier. So this one is where you're going to look back to. So number 6 here. I'm going to zoom out a little bit. So number 6 here, look that up. Number 6 here says we need to draw the following molecules using 3 dimensions. So that's where you're going to look back to building 3D models. You're going to need to draw the structural formula, and then you're going to have a 3D model. So I think that the easiest thing to do in this case is to first draw your 2-dimensional. So you've got nitrogen. Nitrogen has 5 valence electrons. Hydrogen has 1. It's going to have its 3 bonds. But please notice there's 4 sections around that molecule, around that nitrogen. So it's got 4 sections. Then it's going to have 2 that are going to be in the plane, and 1 that's coming towards you and 1 that's going away. In this class, I will not give you any that is going to have more than 1 coming towards you or more than 1 that's going away. So the way that I would draw that, I've got 1 hydrogen in the plane, another hydrogen in the plane, meaning a parallel with the paper. Then this wedge right here, this little triangle, is going to show that the hydrogen is going to come towards me. And then I would then have that lone pair that would be going away from me, something like that. I could have also drawn it like this, where I've got the lone pair and then 1 hydrogen. Both of those are in the plane. I could then have one hydrogen coming as a wedge towards me. I could also then have another hydrogen going away. So that's one way that you can draw that for sure. On your actual assessment, it will be a little bit easier than this one. So silicone tetrabromide. So silicone has the same number of valence electrons as carbon, has 4. You got 4 bromines. On your assessment, there will be, I will not have ones that have so many valence electrons, so this one took a little bit longer to draw, as I noticed. So please notice we've got 4 things coming off of this silicone, so that would mean that I've got 1 bromine that is going to be in the plane of the paper, another bromine, hence there's 2 Ds, there's 2 dimensions. One's going vertical, and one's going horizontal. One has a height, one has a width. And then I get into 3 dimensions. I've got 1 coming towards me, and then 1 going away. So that's how that one would look. Oops, sorry about that. That's how that one would look. So then we've got carbon dioxide. Carbon dioxide is a little trickier. Carbon dioxide, well, maybe not trickier. It's just a little bit, you have to think a little bit more. So carbon dioxide, here we've got one remembering carbons. Oh, I'm gonna do a little line here so it's a little bit easier to see. This carbon doesn't have enough bonds. So if it doesn't have enough bonds and you can't add another atom, you're just gonna do double bonds. So remember, anytime you have anything that double bonds or you got a triple bond, you're not gonna have anything that is gonna be coming towards you or anything going away. It's all gonna be in the same plane. And I will show you more with that, of what that will look like on Monday during your check for understanding. So there's nothing coming towards you, nothing going away from you, anytime you have a double bond or a triple bond. All right, so coming to the last question for this second page, I'm gonna zoom out again. So this next one is number 7. It says rank 1 to 4 the following molecules from strongest, which is 1, and weakest, 4, which is any molecular forces. You could also, in this case, if you wanted to be really specific to make sure it wasn't confusing to me whenever I grade this, you could also write the word strongest and the weakest, second strongest, second weakest. So this is one that you're almost kind of at that stage where you're going to be using the information that we did for the lab. The lab that we had for this class was that for this question specifically is going to be the lab on intermolecular forces and evaporation. So this one you're going to need to rank the molecules from strongest to weakest. So you've got nonane, nonanol, decane, and decanol. So please notice we've got nonane and nonanol. Nonane, nonanol, they are going to be, this has the same number of carbons, but one has hydrogen bonding, the other one does not. This one, decane and decanol, one has hydrogen bonding, the other one does not. Please notice we've got 128.2, 145.3, 142.3, 158.3. Just because this one is actually heavier is not always going to be the case that one's going to be always going to be stronger than the other. So if I was going to say that this one right here would be something that would be the 4. So this would be 4. This would be the weakest. Has the smallest molecular weight, it does not have hydrogen bonding. The next one would be decane because it does not have any hydrogen bonding. It also has a larger molecular weight than nonane, so then that would be second weakest. I'll just write 3. Nonanol would then be number 2 because it is not as heavy as decanol, but it has hydrogen bonding. And then number 1 would be